Okay, the last important property of an inscribed angle that we're going to go over is that when you have an inscribed quadrilateral, the opposite angles are going to be supplementary. All right. The reason why that happens, let's say we have this inscribed angle, ADC, right, intercepts this arc. So I don't know how many degrees this arc is, but I'll call it x degrees. All right. Then let's say this angle, ABC, intercepts this arc. Alright, I don't know how many degrees it is, but we'll call it y degrees. Now I know that x and y are going to add up to 360 because they form a complete circle. So that means that their inscribed angles have to add up to be half of that. So these two angles here, we'll call it, A and B, they're going to have to add up to 180 because their arcs add up to 360 and they're always half the measure of their arcs. So taking that, why don't you try these problems and pause the video here if you don't want to see the answer. Give it a couple minutes of effort, and then when you're done, unpause it and I'll show you the answer. Okay, so this first one, C is going to be 70 degrees. That's because if you know that this inscribed angle is 95 degrees, this arc is going to be double it, so that's 190. Then when you subtract this part, which is 120, you're left with C, which has to be 70 degrees. For M, alright, we know that this angle right here is 90, so that means that this angle also has to be 90 because opposite angles in a cyclical quadrilateral are going to be supplementary. So this inscribed angle is 90, which makes this arc that it subtends 180 degrees. Alright, when we subtract 40 off of that, we're left with angle M, which has to be 140. And then for angle N, it helps to know what this arc is, 40 plus 98, and that comes out to be 138 when you add these two together. So this angle right here intercepts that arc, is going to be half of 138, which is 69. Then these opposite angles in this cyclical quadrilateral, or inscribed quadrilateral, another name for it, they have to be supplementary. So 111 and 69 add up to 180, so N is 111. Okay, and then back when you learned about chords, you learned that congruent chords determine arcs that are congruent. So this is a regular hexagon because it's got 6 equal sides, which means that since it's inscribed in this quadrilateral, right, all 6 of these vertices line up right on the circle, right? It's going to divide the circle into 6 equal parts, 6 equal arcs. So you got 360 degrees, so divide that by 6. Each of these arcs are going to be 60 degrees. So when you look at this angle right here, angle R, alright, intercepts an arc that's 60 plus 60 plus 60 plus 60, which is 240. So this arc has to be half of that, 120.